Hi everyone, Chapter 3 Mechanical Properties of Materials, Mechanics of Materials, Chapter 3 Hooke's Law and Poisson's Ratio. In almost mid 17th century, a British scientist called Robert Hooke came to an interesting discovery. We know it today like a Hooke's Law, which is the linear relation between a stress and a strain. Sigma is equal to E times epsilon. Hooke's law or law of elasticity, which is discovered in 1660, mid 17th century, by a British scientist called Robert Hooke, is just simple relation. Sigma is equal to E times epsilon. We know it like Hooke's law, and another explanation of that is like a force of a spring is equal to a stiffness of the spring, which draws the force times the small displacement of the spring. And Robert Hooke, whilst working in his office with different kind of a spring, there he just came to this interesting discovery. This is a schematic of the devices used in Hooke's experiment while working with different kind of instrument like uh, a spring. He came to an interesting result that sigma is proportional to epsilon. Stress has a linear relation with epsilon. Robert Hooke was born in 18 July 1635 in England and died in March 3rd, 1703. Almost 68 years in discovery, and he discovered and also he has a famous quarrel with Newton, and he just discovered in the elastic region of a stress and strain curve, which is, you can see there are two dots here. The top one is a sigma y yield strength, and the little below that sigma y is sigma pl, which is proportional limit of a material. And below the proportional limit, stress versus strain remains in a linear. So and that was discovered by Robert Hooke. So sigma is equal to E times epsilon, which is Hooke's law. In this equation, sigma is a stress and epsilon is a strain. And but it, Robert Hooke didn't find what this constant is. This is it just took 100 more years for another scientist to discover this a constant in terms of value, and that was nothing but the work of a smart another smart British scientist called Thomas Young, which we know this capital E like a modulus of elasticity or after him or like Young modulus, and it just take almost 100 years later in this simple formula for work of two uh, smart scientists to figure it out how it works. A Thomas Young was a British scientist born in 13 June 1773 and died in 10 May 1829. 27 years here, 29 there, 7 6 7 9 16, 4 and 4, almost 56 flourishing years of a life of a one of the most prolific polymathes in history. And E, capital E, stands for my bad, modulus of elasticity, or Young modulus after him. Let's move to the third person or the third scientist, uh, Simon Dennis Poisson, who discovered the Poisson's ratio. He just simply says if we do have a original sample of any material and we just pull it from both sides, for example, if we just increase the length in axial dimension, definitely in the y-axis it goes by a decrease in size. That's a tensile sample. Vice versa, if we have a original sample and push it from both and definitely it just shrink from the sides and the longitudinal axis, and it just expand in the lateral direction. That's the discovery of Poisson due to conservation of mass maybe on a material. And in the early 19th century, a French scientist called Simon Denis Poisson realized that there is a ratio of lateral to longitudinal deformation, and he called it by like nu, and that's a negative lateral strain over longitudinal strain. And the negative sign here says if you increase one dimension, the other one should decrease. If you decrease one dimension, the other one goes in the other way. That's why the negative comes to play. And that nu stand for lateral strain, negative lateral strain to axial or longitudinal strain. And now let's jump to the relation between the work of uh, uh, these three great scientists, like these material constant of E, G, and nu are somehow related to each other, which are the works of these three uh, interesting person: Robert Hooke, British scientist, 17th century; Thomas Young, almost a century later, 18th century, and another British scientist; and Simon Denis Poisson, a French scientist in early 19th century. So how they are connected to each other? G, shear modulus of a material, which is another way of explaining a nation of Hooke's law in shear, but it's equal to modulus of elasticity over 2 times 1 plus nu work of Simon in parentheses. And Hooke's law has two forms, either in normal shear, sigma is E times epsilon, and in shearing stress, that's shearing modulus times the shearing strain. So the first one is normal strain, epsilon, and the other one is shear strain. Thank you. We'll solve some problems in this category. Thank you.